Lesson 91, effects of scaling on perimeter, area, and volume. In the picture here, you can see they give us the scale factor, which is just comparing the side lengths. So 1 to 2. The areas, you would square the scale factor, and volume, you would cube the scale factor. For review of the scale factors, if dimensions of figures are changed proportionally, then the ratios between them will change proportionally. So scale factor, the ratio of perimeters equals the scale factor. The ratio of the areas is the scale factor squared, because when you're finding area, you're squaring the units, so you would square the scale factor. And then the ratio of volumes would be the scale factor cubed, because you're using cubic units. So let's take a look at an example here. Vince was asked to paint a mural near the city park based on a painting he made in art class. The mural was to be 10 times the length and width of his original canvas painting. Vince bought 10 times as much paint as he used for his original painting, yet he ran out of paint after only a fraction of the mural was painted. Why did Vince run out of paint so quickly? Well, if he increased the length and the width 10 times, the perimeter was 10 times the length and 10 times the width, but he's covering a certain area. So when you find area, you would have to square the scale factor. So he had a scale factor of 10 when he really needed he needed a certain amount to cover 100 times. The area is 100 times the area of the canvas that he used. So why did he run out? He used the wrong canvas, or he used the wrong scale factor. How much paint did he need? He would need 10 squared, which would equal 100 times. And why? Because the area square the scale factor when finding area. Next one, Irene works with stained glass. She wants to make a replica of a stained glass window. Her replica will be related to the original window by a scale factor of 1/3. The original window was made of 3,456 square inches of glass and it has a perimeter of 240 inches. How much glass will Irene use in the replica? Since the area of the original window was 3,456 square inches, the scale factor is 1/3. So when we're finding area, we would have to square the scale factor. So we would have 1/3 squared times the number of square inches, which would be 3,456. So really it's 3,456 divided by 1/9, because 1/3 squared is 1/9. So 3,456 divided by 9 or times 1/9 would give you 384 square inches. What will be the perimeter of her replica? So I use the scale factor 1/3, and since I'm just dealing with perimeter, that's just basic units. I don't need to square it or cube it. So 1/3, and the perimeter was 240. So I multiply that by 240, or it's just 240 divided by 3. And that would give us an answer of 80 inches. Next, the dimensions of a wallet size photo are about half the dimensions of a 5-inch by 7-inch photo. The area of a wallet size photo is about what fraction of the area of a 5 by 7 photo? Well, the scale factor, they said it's about half the dimensions, so half would be the original. And then since you're dealing with area, you would square the scale factor, so that would be 1/4. Next one, a triangle with vertices at 0, 0, 1, 0, and 0, 2 is dilated by a scale factor of 4. The area of the dilated image is how many times the area of the original triangle. Now to help us out with this, it might be easier just to draw a coordinate plane. So then we can draw our triangle. So we have points at 0, 0. We have point at 1, 0. And we have a point at 0, 2. So here's our triangle. So it's dilated by a scale factor of 4. So if we look at the base and the height, this would be 1 times 2. So 1 times 2 divided by 2 would give us a scale factor or an area of 1. And that was each part was dilated by 4, so it increased by 4. So if we were to multiply each of these by 4, so we would have 1 times 4, 0 times 4, 0 times 4, 2 times 4. These would be times 4 here. Instead of this 1 right here, we would have 4. And then instead of the 2 here, we would have 8. So we would have 8 times 4 divided by 2. 8 times 4 is 32. 32 divided by 2 would give us 16. And so we would have the area be 16. It would be 16 times the area of the original triangle. Next one, Nelson built this figure with 4 1-inch cubes. How many 1-inch cubes are needed to build a similar figure with the dimensions doubled? Since we're dealing with 3-dimensional shapes here, and you're doubling each dimension, so that's a scale factor of 2. And since we have 3 dimensions, we're going to cube that because we're dealing with volume. 2 cubed would give us 8. So we would have our dimensions would increase by 8, so that means it's 8 times as many cubes that are needed to build a similar figure. We double the dimensions as shown. So we would take our 4 cubes that we have, multiplied by 8 because it's 8 times as many. That would give us a total of 32 cubes. Next one, find the scale factor of the smaller rectangle to the larger rectangle, and find the ratios of the perimeters and the areas of the larger rectangle to the smaller rectangle. We know that the length of the small one is 2 and the length of the bigger one is 6. So the bigger one is 3 times as larger than the smaller one. So we would say scale factor is 3. And then it says find the ratios of the perimeters and areas of the larger rectangle to the smaller rectangle. So the perimeter scale factor would equal from larger one, 3 to 1. And then the area scale factor ratio would be, so now dealing with area, we would have to square each part. So 3 squared would be 9, 1 squared would be 1. So you would have a scale factor of 9 to 1 for the area scale factor. Next, find the surface area and value of a 1-inch cube and a 10-inch cube. So for surface area of the 1-inch cube, I have 6 groups or 6 squares of 1 square inch. That would be 6 square inches. The value of the 1-inch square cube, we would have 1 times 1 times 1, which would equal 1 cubic inches. Now if we do the 10-inch one, the surface area of the 10-inch cube, and we have 6 sides, and each one is 10 by 10, so that's 100. That would give us 600 square inches. And the value, we have 10 times 10 times 10, which would give us 1,000 cubic inches. What is the ratio of the surface areas? So the ratio of the surface areas, we compare the surface areas at 6 to 600, which would equal 1 over 100. And then we have the ratio of the volumes, which is 1 cubic inch over 1,000 cubic inches. So this would be 1 over 1,000. One square has sides 10 centimeters long. A second square has sides 50% longer. How long are the sides of a larger square? So if they're already 10 centimeters, it's 50% longer. So that means that's multiplied by a scale factor of 1.5. That would give us 15. Or you can think of half of 10 is 5, so 10 plus 5 would give you your 15, so 15 centimeters. What is the scale factor from the smaller to a larger square written as a decimal? So the scale factor is actually 1.5. I figured that out here. And all we're doing with that was it's a 50% increase. So 50% increase, that would be 1.5. So it's really 150 divided by 100, because the original is 100. If it's 50% more, 150 divided by 100 equals your 1.5. And what is the ratio of the areas of the smaller to the larger square written as a decimal? I would just take my scale factor of 1.5 and I would have to square it, and that would give me 2.25. And our last problems. To celebrate her pizza shop's 10th anniversary, Laka is offering double your dollar days. During this time, customers can get twice as much pizza for the price of a 10-inch pizza. What is the approximate diameter of a pizza? Twice the area of a 10-inch pizza. Well, first off, we need to find the area of a 10-inch pizza. And a 10-inch pizza would have a radius of 5, so 5 squared times pi, which gives us 25 pi. So twice that amount would have to be about 50 pi. The only one that would have a diameter that would have an area of about 50 pi would have to be B because the diameter is 14. So the radius would be 7. 7 squared pi would give us 49 pi, which would be about the same as 50 pi. If you did this one, 20 inches, that would be 10 squared, that's 100 pi, too big. Half of 16 is 8. 8 squared is 64 pi, that's still too big. Half of 12 is 6, so 6 squared will give you 36 pi. That is also too big. So B, 14 would be the correct answer. And our last one, if a 6-inch diameter balloon holds a pint of water, how much balloon does a 6-inch radius balloon hold? So for this one, a 6-inch diameter, so we're looking at volume. So we're going to have to cube our scale factor. So for 6-inch diameter, that has a radius of 3, so 3 inches. And the other one has a radius of 6 inches. So this is a scale factor of 2, because 3 times 2 would give us our 6. So we have a scale factor of 2. Since we're dealing with volume, I have to cube it. That would be 8. So this would be 8 pints, or 1 gallon. That is our lesson today on the effects of scaling on perimeter, area, and volume.